Hello, world, and welcome to first episode of a new series. I'm calling Advanced Wars AI. So this is going to be something where I'm going to basically be playing a video game that I have. It's an old Game Boy game that I have an emulator for. And instead of just playing the game, I'm going to code various AI algorithms to kind of play the game. Maybe we'll have them compete against each other, see how quickly they can beat the game, and do various kind of fun things with artificial intelligence. For this series, I'm going to be using Visual Studio's Code as my editor, which you can see I have open right here. I'm also going to be using Python and Git. Git for version control. Python is going to be the language I'm going to kind of code it in. So those three things I already have installed and are the prerequisites for this. The other thing that I have that I need to use for this is this emulator with the game. So this is Visual Boy Advanced is the name of the emulator, and then I don't remember where I downloaded the game from because that was a while back that I did that. So yeah, those are kind of the only things that are needed for it. It's I wanted to use this because this is it's a little more of a complicated game than building kind of AI to just play, say, tic-tac-toe or Connect Four, or kind of, you could kind of code up that game pretty quickly and then write AI to solve it. Similar with different puzzles like Sudoku or any kind of sort of game in there, like a Wordle, AI solver or something, right? Like this one's a little more kind of advanced in the gameplay, right? Like you take something like tic tac toe and you compare it to something like chess, which is much harder to kind of solve against, right? This has kind of that variety of different options that can occur, making it a little bit more challenging and I think a little bit more fun to do. So yeah, let's get started, and I'm going to basically do the project setup first. So right here, I created a directory called Advanced Wars, and as you can see here, it's empty, right? So if I type dir, nothing in here yet. Don't even have Git installed yet, right? If I try to type Git status, there is no installation of Git or anything else. So the first thing we're going to do is we're going to set up the project. I'm going to use Git as the version control. So basically, it's very simple. Just type Git init. And now if I check the status, right, I have Git installed. If I type dir, it still shows nothing. But there actually is, if you do, this should come up, right? If I type, so it's a .git file, so that's why it's hidden. And you can kind of see all the Git stuff in the background. All right, so now I got Git installed here, but everything else is kind of clean. The other thing that I'm going to install for this project, for this Python project, is a virtual environment. This will allow me to download different Python modules to use in this that won't conflict with other projects, or just generally with kind of my basic setup of everything. So I'm going to type python-m and then install venv under venv. Okay. So I type that. That'll take a second to run. And this is installed, yeah, so like I said, this is installing a virtual environment. This will allow us to have the different packages. You can kind of see it came up here in this venv. It's got various things that are kind of in it. An activation script, a deactivation, various Python setup, and all these different kind of things, right? So that's just going to be installed as is. Now, I'm going to create a git ignore file and just ignore this because this is just kind of like part of the setup, so it's not anything that's actually dependent on the project, right? You don't need it to do anything. So I'm going to create a .getignore file here, and then in the getignore file, I'm going to add in venv. And now, as you can kind of see from up here, this went from being this unmerged or untracked to being grayed out, right? And so now if I check get status instead of the venv, I'll actually have the .getignore here. And so the other thing we could do, so we'll do so now we'll activate it. So we'll go open up the scripts, type activate, and now we've started the virtual environment, which you see here. So now if I type pip freeze, that'll show what modules I have installed, which is nothing. So I'm going to create an empty requirements .txt, which I'm blocking myself on. So I have the requirements.txt. That's going to have nothing in it, but I'm going to just create the empty one to start with, right? And I'll call that for the project setup. So if I go get status, right, you see that I have these two files, the .getignore and the requirement. So git add everything in. So now they're staged, and now I can commit them. So I can do git commit setup project basics. And now if I check the log, right, we'll see that I have one commit with those project basics, which are those two files that I added. And now that's all basically saved in the kind of the history of the project, right? Essentially what Git is doing with the version control. So now we're basically ready to start the prototyping. The one thing that I'm going to do here with this game is just to start with, I'm going to well, I guess actually I'll do it from the main screen. So this is from the main screen, and let's start with this. Let's create some code that will verify that we're able to essentially interact with this and kind of click through certain things, and we'll do that so that it'll click through and start a game, right? So from the main screen, we'll have it start like a basic game on a map, right? So I did test out a few different libraries to see what might be like a decent library to use for this. Essentially because the there are various kind of libraries that can allow you to automate like mouse clicks and keyboard keystrokes and type different things and whatnot. But I wanted to make sure I could find one that would definitely be able to interact with the emulator, because if not, then the code can't actually do anything, right? Because I think at a basic level, when you're thinking about it, there's various aspects to creating this sort of AI that can play this game, right? One, it needs to be able to it needs to be able to actuate. It needs to be able to actually manipulate the game, right? And so if it wants to do something, it needs to be able to make those moves. Otherwise, it's just telling me what to do, and that's no fun, right? I wanted it to play the game. The other thing it needs to be able to do is be able to tell what's going on in the game, right? So be able to ideally read the screen, see what the game state is, right? Where all the different units are, what the map looks like, and use that information so it can, update its knowledge of the game, that it can then make its decision on and actuate, right? So those are the two kind of ends of any sort of kind of what it's called an intelligent agent, right? So the agent needs to be able to read its environment, perception. It needs to be able to act on its environment through actuators. And then inside, there are then kind of two components that we kind of then need to build out for the AI to be able to do those things intelligently, right? One is it needs to have knowledge. It needs to have an internal representation of the game. The other thing it needs to do is be able to reason, or essentially it would need to be able to plan, right? It needs to say, this is what the game looks like. This is what I think I need to do to win. And it needs to figure out what. Okay, so based off of this, I want to win. What do I need to do, right? So those are kind of the 4 stages, right? Read the game board, update its knowledge of what the game looks like, plan out how it thinks it can win, and then make its move, right? This is a turn-based game, and so while it could do stuff kind of live, this is like I said, more similar to say something like chess, right? So the first thing we're going to do is the interaction, right? We have to make sure we can interact with the game. The reading of the game is a little, it's not more complicated. It's just something we'll have to code up. So initially, to get kind of some of the AI stuff going, I might skip that, and we'll just use one map to start with, because then I can just kind of hard code that. I can just create a representation of that map. And then we could always input kind of computer moves and then say, okay, now it's your turn, go, and it'll update its kind of knowledge base, right? So we'll get there. But yeah, so the first thing that I want to do is interact with the game, and I tried a few different modules, like I was saying, to do this. One was Pi Auto GUI. That was having issues with the keyboard interaction. I also tried the keyboard module. That wasn't really working. And so what I settled on was Pi Direct Input. And that was able to use the arrow keys and the various, it's like Z, like the keys that essentially map to the emulator. It was able to use those and move stuff around when I tested it out. So that's what we're going to use here. So that's the first thing we're going to do, is we're going to install, we're going to do pip install Pi Direct Input. And now if I type pip freeze, what you'll see is now we have this one. So the other nice thing about this one is, unlike Pi Auto GUI or the keyboard module, this is the only module in stars. It's not like a set of 5 things that it's dependent on. It just has this. So it actually also kind of keeps our thing short. So we'll update the requirements for this. And you see requirements got updated. So then we'll commit that. So we'll say git commit AM, and we'll update basically the history and say installed Pi, we'll capitalize it the same, Pi Direct Input. All right. So now that we've installed that, we can essentially kind of get going on what we want to do here. So I think the first thing, so let's create a prototype file. And we will say from, was it Pi Direct Input, import, what do we need? We need, so we're going to need press to do the actual key commands. We're going to need click, which is the mouse click, because I need to select it. So if basically when I run the code, I need it to kind of go over and select. So the other thing we're going to need is move. We'll do move to. Right, so I'll move this. I'll make just alphabetically. Right, so these two here are going to be used are for the mouse. And what we're going to do is we're going to have the mouse move over to the screen that I have the Advanced Wars on, the emulator, and then we're going to click. So I'll click into it, which will basically make it, right, so here, just to demonstrate, if I start this mode, right, so as you can see, it's kind of frozen because it's not highlighted. So the move to will move the mouse over here, and then it'll run a click, and that'll kind of get us right in to this, right? And then what we will basically need to do is, in this case, I think hit Z. right? And then so Z is the A button on like a Game Boy. So we're gonna hit Z a few times to click into creating a new game. Then we're gonna select a map. I'm gonna start with this map here because it's very simple. So we'll need to arrow over, click in. That's fine. We're gonna turn the fog of war off so that I can see all the units, so that we can kind of input everything. In future, right, we could turn fog of war on and see if it can kind of still play with that. And then we'll turn random. We'll just turn weather off so it's clear, right? It's just kind of making the environment very simple. And then it'll click Z again to kind of enter in the game and start the game, right? So let's exit out of this map for now. And so let's see if we can basically code it to do that, right? So starting from this screen, we need to hit Z like 3 times and click into things. So let's come back here. All right, so the first thing we need to do is we'll need to move here, and we'll need to click. So basically, the way this works, right, is I have 3 monitors set up right in front of me, and they all, right, I can move the arrow key to kind of any of them, right? So if I say move to, and I want to say, let's say 1500. And we'll do 500. All right, so now let's say I run this. So notice where I have my mouse here, right? And so I'm gonna type this, and when I run this, it's gonna move the mouse. So where did it move the mouse to? Okay, I moved it down over here somewhere. I'm gonna run that again. Okay, so right here. So it looks like 1500 is about actually where this edge of the screen is. So let's update this to 2000. And it should move it then somewhere around here. Yeah, so see, that's where it moves it, right? So what I need to do is I need to move it basically to this other screen. So I'm going to cut this down. Let's just cut it in half to start with, right? If 1500 was kind of the edge of the screen. And what I'm going to do is I'm going to open up this screen, right? So I'm basically going to come over here and do the same prototype. And we'll see where on this screen here that it kind of like shows up, right? So I'm going to run the prototype, and we get it right here, which is, I mean, pretty good. I think if we just make it, maybe I'm going to update it to say 800, and that should be around the middle of the screen. Yes, yeah, so that's about the middle of the screen, right? But I haven't like clicked. As you can tell, it's not really moving or anything. So the other thing, I was looking at the mouse there. All right. So the other thing I need to do is basically run a click. So I'm going to come in here, and I'm just going to do click, and that'll do mouse click, right? So now, oh, I wasn't showing it. I forgot to turn the screen off. All right, so yeah, so I just basically added click in. So now I'm going to show the screen again, and I'm going to run the prototype, which should move and click. And then as you can see now, the press start is flashing because now we've clicked into it. So I'm going to come back over here. The other thing that I want to do is I'm going to import sleep because it's going to move, it's going to click, but I want there to be, I want to make sure it has enough time to kind of register that it's clicked in. If it immediately starts to try to type keys and we're not like ready for it, it could have kind of an issue. And actually, as I'm talking, it went back to this screen here. It started running that again. So we'll have to see about maybe clicking through this as well. I think this, if I click this and I just hit, if I hit A, it'll just open up, right? So I can hit A, but we have to wait for then this animation to start. So we're going to wait like a half second to kind of get this to start, right? So let's import. We'll come in here and we'll say from time import sleep, right? And so so what we'll do is we'll move to that spot and then we'll click and then we'll sleep for, this is in seconds, a half second, right? And then we will do press. And then Z is the like games like a button. For now, I'm just going to I'm just going to do that. We might like pull that out into like a function so it's easier to kind of to call. But for now, we'll just do like, so press Z, right? And that'll like advance things. So, oops, save. Okay. So now I'm going to open up the screen again, right? And so basically I'm going to run it. It should move there. It should click. It'll wait a half second, and then it'll hit Z, which should go to the next screen. All right. So now we're on the screen. We won't be able to hit it again immediately, right? So we were on this screen. We hit it, and then I can't hit it again. I have to like wait a little bit, and then I can hit it again, but these can be in like faster succession. So let's see if I can wait maybe another half second and then hit it twice to get to this screen, because this animation is faster. All right, so we'll come here. And we will, so we clicked in, we have to wait another half second, 0.5. And then we're going to copy this, and we're going to see if we hit it twice, if we can get to then that next screen. So let's bring this up. And now that should basically be ready to go. So we'll click in and start. So it clicks in. And it looks like those executed too quickly because it didn't, nothing happened. So I'm going to back out of that again. And we're going to come back over here to this screen, and we're going to wait. It's a fairly slow screen. I'm going to try 1 second. If not, I'll just bump it right up to 2 seconds, and that should be plenty of time. So let's run it again. And we click in, wait a second, and it stopped. So it was just barely too slow. But let's just bump it up to 2 seconds. And then do it now. Now it should work. Now it should be able to do it. Yep, both of the clicks went through. So now we need a right arrow key. We'll have to wait another like half second probably, and then hit A. And then there's another quick animation, and then hit A. So we'll have to hit a couple A's. So let's try this. So back all the way back out. Okay, let's come back over to the code screen. And, all right, so from here, we've entered into the thing, so we need to right arrow, and the way to do that is, so I'm gonna wait, I'm gonna sleep for half second, and then I'm going to press, so to do the arrow keys, they're just like the words, right? So it's just gonna be right, sleep for a half second, press Z again, sleep for a half second, and press C again. Okay. So now let's try this. So it clicks in, does the 2 Z's, goes right. I got an error. Oh, I wrote the wrong thing. So if you look at the code, it says sleep Z string object. This one, these were supposed to be press, not sleep. Okay. So save that. Locks it back out. Looks like it's working. Okay. And now let's run the code again. So click through. So we're getting the interaction right. It's basically kind of right what we're looking here. All right. And so we got through to everything. Now let's see if we can do this without any extra sleeps. Right. So far this takes about, we have 4 half-second sleeps and a 2-second sleep. So it takes about 4 seconds for it to click through, which honestly relatively fast for something that we're just going to be doing once with the animations. I actually have all the visuals turned off in the game itself already because that's how I just ended up playing it. So everything kind of also moves rather fast in the game, so we shouldn't have to worry as much about like kind of sleeps and stuff. So okay, well, so what do I need to do? I need to do a down, a right, a down, and then an A. So down, right, down, A, like doing all right. So switch back over. So let's try press down, right, down, and then A is Z when I say A. All right, so open this back up, and let's see if we can start the game. All right, clicks through, starts it up, goes. Perfect. Now the other thing that we can do here, so we basically started the game up properly. The other thing that we can do is the emulator allows hitting the spacebar to speed things up, right? And so if you noticed when it started, it was like day 1 and it wrote it out slowly. So I'm going to add that as like a last piece of this. Let me see. So they have key down. All right, so I'll do, well, I guess those are going to be over here. So we're going to have key down and key up, right? And because what we want to do is we want to basically hold the space bar. So we're going to come in and we're going to say, make sure do I have the right screens up? Yeah, good. All right, so we're going to come in and we're going to say key down, space, sleep for 1 second, and then key up, space. All right. So when the game starts, once the game starts, it'll basically take a second to speed everything up and should get us to kind of this initial screen of playing much faster, right? And so I'm going to come back here and I'm going to quit the game just to start the whole thing fresh. And then what we're going to do is we're going to wrap this in kind of a quick method, and then we won't have to call it again. We'll just be inside the game. We could have something to we could code something to kind of quit the game and get back to the other screen if we see that when we're kind of testing stuff, we want to just like exit and restart it, and then we can like kind of run that. We can kind of like run methods like real quick to restart the game. And to start the game, restart the game, and that way we can kind of get fresh stuff as we're going. So we'll see if that becomes necessary. All right. So we're here, and I'm going to run what we just wrote. I don't think I can speed these in. Actually, I guess I could speed those animations up. Yeah. So see how that went much faster. I'm going to try 2 things. First thing I want to try is I want to see if I hold the spacebar while it does this, like while I'm doing the prototyping, if it will speed up like while it's doing all its other stuff, like if it can handle both my inputs and the program's inputs. So I'm going to run it again, and it's clicking through. Okay, and so it is actually going significantly faster. In fact, it got confused. It was going so fast that it was having issues. So what I'm going to do to not have to sleep as long is I'm going to, right, so we're going to be here and see if we can do like instantaneous clicks if holding the space bar allows for instantaneous clicks. So we can take out the 5 seconds that it basically takes to start up. So I'm going to come over here and I'm going to move this key down. So we're going to click, and we will then, so we'll click, we'll hit space, and then we'll wait a half second. And we'll wait a half second here. Well, we'll wait a quarter of a second here. Let's wait a quarter of a second, not a half second, because it should be fast. So, and then we'll remove these sleeps, in here and see if it can handle that speed, right? So basically we've cut down the 5 seconds into a half second by wrapping the entire thing that we're doing there in the space bar. All right, so I'm going to come here. Game's already loaded, and let's try it out. Let's see what happens. All right, so what it looks like happens is it goes. So it does this. It does that, and oh, okay. So the click, all the clicks are good as like single clicks, except this one. When it hits A there, if the space bar is open, it can't handle it. So what I need to do is basically take the space bar off before I hit this click. So it'll click in, and then I can turn the space bar back on again. So which one is that? So the AA, so I think it's this A because, or no. So AA, this is the one that selects the game, clicks into it, and then it's this one here. So here we're going to key up space. We're going to go key down space. Okay. And now let's exit back out to the main screen and rerun it. So it clicks through. Okay. So it. Okay. I don't know if you, I caught what happened there. Otherwise, it would be not very obvious. So it looks like these couple screens, because there are like no animations, the arrow keys and everything are getting confused where it's like jumping. Right? So certain things here, right? Like if I hold space and I click it, right? If I just click, it's fine. So if I'm holding space though, it will jump. While in other screens, right, and it's the same thing with kind of these. While in other screens like this one, if I'm holding space and I just click once, there's enough of an animation that of like the thing moving that it's the same as these clicks. So once we enter this screen here, we need to do this whole thing without, like, we need to do this whole thing without the space. But I think we don't have any of the sleeps in, so so I think we're going to be, we might be okay to still not sleep. We might still be able to just go down, boom. Like, it looks like this flows fine and just takes the inputs. So we'll come back over here. So we have to key up before this one. I'm going to take the key down and I'm going to move it back here after we start in. So we're going to hit in, do all that stuff, start the game, and then we'll do a quick speed up to get to the and to get to the whole thing. All right, so we'll save that, come back over, exit to the main screen. All right, and now we will run this. All right, so this is all good. Clicks through, that's fine. Clicks those. And it looks like we could have waited. It looks like it stopped a little too fast. In fact, what I'm going to do is I'm going to come into the code and I'm going to go press right. So it'll lift up the space, and if this sleep is too long, it will kind of kick it off. And see, this is where I'm saying, like, oh, having something that I could just run that would like bring it back to either this menu or something would be nice, because then I wouldn't have to do all that. But all right, click through, slows down, clicks those. Yeah, see, the arrow key didn't move it. So let's make this a half second, and we will exit out. So I updated the sleep to a half second and running it again. Okay, that was perfect then. Okay, so now that that works, let's come into here. And we'll get rid of that because we don't need it. And we'll say git commit. Actually, did I? Okay, I have to add the file. Git add, and now I'll do git commit -m. Wrote code to start simple game. Okay. All right, so now let's come in here. We'll get rid of this and let's add some comments to what's going on here. So we'll say what's the word for it? When I like if I were to tab switch between something to make it active. So we'll say make emulator active app. Start speed up. Enter this one is entering the menu screen, we'll say. So this is a select mode menu. Enter menu screen, start versus game. All right, so we're here. Click it twice. This one is select little island map. All right, so that's doing the right Z. Slowing down for what's the word for it? We'll say like battle options or battle. Okay, battle options is fine. Slowing down for battle options. Accept COs. And then set rules. And speed up. Well, actually, we can move this one into here. Or we can move this one after the space, right? Like we can start the space and then do that. So we'll say speed up for speed up and start battle. All right. And we'll just commit that real quick. So we'll just git commit added comments for initial setup keys, right? Because these are kind of, it's not necessarily obvious what each one of these are doing, so by adding that kind of in there, that helps. And then let's move this all into a method. So we'll say def start little island battle. Start little island battle. Make emulator active. All right, yeah, that's fine. And then we'll add another comment. Should be on. What's the word? Should be on title. We'll say should be on title screen. Title screen. Emulator should be on title screen. And then I'm using Control. I'm holding Control Alt and using the arrow key to highlight all these, so I can just hit Tab once, and that'll tab everything. And we'll just say start little island battle. Yep. Let me spell it right. Okay. And let's run that. So we'll open this back up. And so now we're running the exact same thing, except we're just running it all as like that method. And so now in the future, right, we could basically say, hey, do this, and now you're at the game start, right, and then like set certain things and then do certain things. So we're running that, clicks through everything nice, starts it up, and we're ready to go. And the slide, you could kind of see, if you're paying attention at the very end there, you could see the slowdown where the space key came up came after this was like ready to go. So all of that is good. There's one other thing I want to do here. I'm going to say, what's it called? What's the? Let me see if I can find it. So I'm going to add a hold on. Come in here. Okay. I'm going to add a configuration so that I can basically type the prototype and run like that method, or I can run like the other methods that we're going to start kind of adding to try to like figure out what things are kind of going on there. And so I need to find something. This one does it. All right, so basically I'm going to use, okay, so I have other like kind of code that like does this. So we're going to come up here, we're going to say from argparse import argument parser. And we'll come in here and we'll say if main, or no, if file, right, equals main. So right, this here, well, all right, before I do that, let me back up real quick. I'm going to commit this. I forgot to do that. Git commit am. Moved setup keys into method. Okay. Now we'll come back and we'll add all that back. All right. So this here we're adding in. So if this is run, so the way we're running it here, Python prototype, it's running in the file, the double underscore dunder file is equal to this string main. And so anything that's in here, if we put this method in here, what that means is this method will then run basically the way we just wrote it, where it was outside of anything. But what this allows us to do is, right, like in Python, if we were using this Python file as like a module and like having functionality, we could add stuff in there that if you run it, it'll do that. But if you import it, right, it won't run this method because it's not, this here is not equal to main, so it won't run this method. So you can kind of have like, you know, your functions that I can then import into other places, but also have this here. So that's all. All right, so what I'm going to do is I'm going to create a parser equal to argument parser, and I'm not going to add a description. I'm going to say parser.add argument, and we'll do a so we'll do here start or -s. So if I give either of those two commands, now I know, what is it, type action. I feel like I need to Google this. Argument parser Python. Okay, that's not what I wanted. Boolean? Action, Boolean optional action. All right, so it looks like post Python 3.9, there's like an action, but I'm going to use the older one, which is just doing action equals store true. And we'll say destination equals start. I think that'll work. But let's figure it out. All right, so let me check real quick. Okay. And then, all right, yeah, that should work, I think. We'll try it out. So we'll say args is equal to parser dot parse args. And then we can just access them through args dot start. So we'll do this. We'll just print that. Okay. So now, if I type Python prototype, it's not going to do anything with the game anymore. Instead, it's going to run this other code that we just added in here, right? And so if I run this, it's basically just, it's setting up an arg parser. This is the only argument that we accept. And then we're calling parse args, and then we're printing it. So it should just print something. All right, so it printed nothing. And let's try -s. No. All right, so it's not working. Is what it looks like. So it is it printing? Is it even actually printing something? Did I get that part wrong too? Looks like it's not even printing something. I think maybe I got this wrong, would be the assumption that I have. So let me just real quick check. Oh, that's why. It's not file, it's name. If name is equal to main. So now if I do this, now it should work. Ignoring explicit argument tart. Oh. All right, true. True, false. Perfect. All right, so basically if we add either of these two arguments in this way, start or -s, this variable args.start will be true. So if args.start, otherwise it's false, then we can run start little island battle, right? Get rid of that, move that there, right? And so now, and that gets us from the start screen into this thing where we can start doing certain stuff, right? And so what I'm going to do is we can now basically, get to this spot whenever we want, which we don't now need to do anymore. But we need to basically like start doing stuff here, right? So if I use the arrow keys, I can basically arrow kind of around. If I hit A on something that's inactive, it'll open up this menu. If I hit B, it'll just allow it to kind of like look around and stuff. And if I hit it on something that I can do something with, it'll then interact with it. So this is a base, and so I'm able to, interact and build units on it. If it's a unit, I'd be able to kind of move the unit. So here's basically where, to start with, we're going to just kind of do interactions with things, and, build units, move them around. The game will need to have kind of an internal representation to kind of what's going on. Otherwise, it will not kind of. It will need to like know where like certain units are, and it'll have to be able to kind of track them. It'll be able to know what the map looks like, and so we're gonna have to create a representation of that. But we're not gonna start right there. The first thing we're going to do is we're going to assume that we're starting with this map ready to go, and that we know where the bases are. And let's say we have 3,000. So let's say we want to build an infantry, and we can't build a mech because we don't have enough money to do both. So we'll build 2 infantry. We'll build 1 infantry here and 1 infantry here, right? So we'll assume that that's where we are. So the first thing is we have to know where these bases are so we can move to them. We're going to have an ability to move around, and we're going to have to know where we are currently, right? And so there's multiple ways to do that. So for example, I think the cursor is going to be left wherever it was. Let's actually try this. So I think if I move the cursor here, and then I do end, we come back around, the cursor is in the same spot that I left it, right? So it can always know where the cursor is. Like one option would be to say move over until you hit the end of the map, and move down until you hit the end of the map. And you can do that very quickly if you just hold space. Like even if I was up here and I held space and tap 2, 2, and 1, I could get to this point of the map, and I'd always know where I was. But we can also store that information. We could say, okay, currently you are at this location, which if we use this as 0, 0, would be 2, 2. And you have a base at, this location and this location, right? So this is, the cursor's at 2, 2. This is at 1, 3. And this is at 3, 1, right? And so you can basically say, okay, move to 3, 1, build a unit, move to 1, 3, and build a unit. So let's kind of just start with something as simple as that, right? So what we'll do is then we'll say, so if start, do that, right? Otherwise, we'll create another method in here, and we'll say, or actually here, I didn't commit it again, so we'll do that too. So we'll say git commit -am added arg parsing start game. Okay, so now we're gonna add another method, which we'll just say def main for now, and we'll add that here. So it'll optionally start, and then it'll call main, right? And so in here, let's actually no, I'm just gonna start with a class, because that way I have the I can have internal storage, right? So we'll say class game, right? So we have a class that represents the game, and we'll initialize it, and we'll give it we'll initialize it, we'll need self, and we'll initialize it and say self.x, self.y. So this is the current location of where the cursor is, and we know that is at 2, 2. And so then we can come, and then so we can come in here and we could say, we can basically create that class. So after you start, we'll say G equals game, and then we'll do, and then we'll have a main in here, right? Def main self. Okay. So right now, basically, we added in this information that we know where we are. The other information we'll need to know is where the two bases are. And so let's say, you know what, let's do it as tuples because they're always going to be XY pairs. So we'll say self.loc. So the location is going to be equal to 2, 2, and that's going to be XY. All right, there we go. And then we're going to say self.bases is going to be a list. And we have one base at, we said 3, 1. And we have another base at 1, 3. All right. And so let's just start with writing something that can basically move to both bases. And so basically we'll want to say, so we're currently at that location. We want to move to the base. So we need to basically kind of like move relative. And we need to do it through like key commands, right? And so we'll basically, what we'll use is we'll use like basic kind of like geometry, like math, to see what's going on. Interesting. So yeah, so we're gonna use we're just gonna use basic geometry here, right? And so we'll need something that will be able to move location, right? And we'll say 2, and that'll be a tuple. So we have the current location, loc, and we want to move to this location, right? And so let's create like a hypothetical, right? So currently we're at 2, 2. So this is loc. And then we have the location we want to move to. And let's say we're going to move to the first base, which is 3, 1, right? So we can, mathematically, we can do that. We could say, if we said 2.x, which is this first value here, and I mean, technically, it's going to be 2.0, but just for now, it's like 2.x, and we subtract loc.x, right? That's going to be 3 minus 2, which is equal to 1, which is what we need to do. We need to move plus 1, right? So that's plus 1. Or we need to move right times 1, right? And then the other thing is we have 2.y minus loc.y, and that's going to be equal to 1 minus 2, right? This 1 minus this 2, and that's going to equal negative 1, which means we need to move down because we're in the y by 1, right? Which makes sense when you look at the map. We're at this location here. We need to move down 1 and right 1, right? So that mathematically checks out, right? So this is basically the logic that we need to add in here. The other thing that we could do is we could make sure that we stay within the screen. And so one thing I'm going to do is figure out how big the map is. So if this is 0, 0, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's 9 by 18 is the map size. So let's add that information here. So we'll say self dot map size is equal to, well, actually it's 18 by 9 for XY, right? And so we know when we're moving, right? We'll be able to kind of figure out. So basically, we know relative what we want to move. We know where we want to move to, and so it right. We can basically just check the 2, right? We don't need to kind of check if we know where we are and we know where we want to go, right? That. As long as, right, the way this math kind of works out, we don't need to necessarily check that, these values. Essentially what I'm saying is if I do this math like this, and then I get +1, I don't need to make sure +1 of my location is within bounds. I just need to make sure that this is within bounds and this is within bounds, right? So let's just say def is within bounds. Point tuple. And so we'll say if point 0, let me make sure, I don't use tuples often, so let me just make sure if I have a tuple, say 1, 2, and I do 0, 1, yep, that makes sense. What if I do like, no, okay, yeah, so, right, makes sense. Yeah, so point 0, this is the, and then actually we don't need that map size here. We can just add it into this. So we'll just say underscore map size. So point 0 is greater than or equal to 0. Or no, we'll say, yeah, if point 0 is greater than or equal to 0, if point 0 is less than 0, or point 0, so wait, 1, 2, 3, 4, 5. Yeah, so it would have to be greater than map size, because when I counted them, I was counting from 0, right? So there was 9. There's actually 10 rows up and 19 rows across, which is because it's an odd size map. So we're going to do 0 here. So if it's less than 0 or greater than the map size, return false. If point 1 is less than 0 or point 1 is greater than map size 1, return false. Otherwise, we can just return true, right? So now we have something that's within bounds. And so we can basically just start with this and say, right, we know we're within bounds, we're at 2, 2. And we can say, if not, and I need to add selfs to these. Self. If not self dot is within bounds, 2, raise exception, move lock, 2 point out of bounds. Okay, so now we know that the position we're moving to is within bounds, and we're raising exception if we try to do something we're not allowed to do. So now we can just say that the location, or like, there's 2 things we have to do. First, we have to move to the location, and then we have to update the 2, right? So we're going to switch this code to move to the location, and then at the very end of the method, we're going to say self.loc equals 2, right? Because the location we're then at is that location. So now we have to basically do this where we want to say for I in range, and this is going to be 2 0 minus self.loc 0. We're going to press, well, okay, actually, so this is what would, because it has to be if it's positive or negative, so we have to know if we're pressing right or pressing left, right? So we're going to say x count is equal to 20 minus self.loc 0, right? And then if x count greater than 0, we're going to say, then we're going to, so if it's positive, then we're going to go x count, and then we're going to press right, else we're going to go left. And if it's negative, then we'll say times -1. So that's correct. And we don't need I actually, so we'll just say that. Okay. Let's just test this real quick with just kind of basic things. So let's say 4 in range 3, print hello. All right, so yeah, we get 3 hellos, and if we have negative, nothing happens, so we need to make it positive. So all that checks out. So now let's do the same thing for the y. And so we'll say y count, this is 1, this is 1, update this to be y count, and if it's positive, it's up, if it's negative, it's down, right? And then we update our location to that, so now we're at that location. So now all we have to do is say, like, move here, move there. So to start with, we know we're at 2, 2, and then we're going to say, in here, we're going to say self.move loc, and I'm going to add an E here, move loc, and then we're going to move to self.bases 0, and then we're going to move to self.bases 1. The other thing I'm going to add in, we'll say self.hq is equal to 2, 2. All right, so we kind of have these locations of these 3 buildings that we have, and then so what we're going to do is first we're going to move to the one base, then we're going to move to the other base, and then we'll do self.move loc self.hq. All right, so let's come back over here, and we can run Python prototype. Now, since we're not doing the dash start, right? We're not going to do this portion. We're going to create game, and then we're going to run the main, which will do all these moves. So let's try it out. Oh. Now that I think about it, I need to still click into the game. So what I need to do is, we're going to come back over here. So I need to click into the game because I didn't do that. So so we're going to say def make emulator active app. Okay. And now, now that I move that there, we have to, like, so we moved it out of here. So we can either put this in here, or we can just call it here. Because no matter what I'm doing, the first thing I want to do is make sure the emulator is the active app. So instead of calling it here and then calling a bunch of spots, I'm just going to call it once here, make emulator active app, if start, start little island battle, and then otherwise we're running this. So now I will come back over here, and now I'll run it again. So I'll come in, and so we move to the one base, the other base, and back to the HQ, right? And I can just run that again, and it does everything perfectly fine. I can't speed it up as I do it, because then when it tries to do the clicks, it'll end up at the wrong spots. This has to be done at regular speed, otherwise I'll end up, it might always be the same location, but I don't know if it's really worth trying to figure out how to, and you can't go top to bottom, so you have to do it like this. All right. So now if let's say we move over and we're at this location, it's going to make the same pattern. So I'm going to come here and I'm going to come in and I'm going to run again. It's going to make that same pattern where it goes, it's trying to go from here down over here and up here. So instead it's going to go here, down here, up here, and then back to that same spot. Perfect. All right. So now let's commit this. So we'll say so let's do two. So we're going to go git command dash I, or git add dash I, patch, and we are going to accept this chunk, say split this one, no to that, yes to that, no to that, and then we're going to quit. So if we go git diff dash staged, right? So these are the thing that we currently have ready to commit. If we check out the status, right? We have the file here, and we have staged stuff here. The staged stuff is that we created the make emulator active app, and then we are calling it here instead of calling the stuff in there. And so I'm going to commit that separately because it's different than the other code that we've been editing there. So we're going to go git commit created make emulator active app outside of start method. Okay, so now the other thing that we have, so I'm gonna make those, close those out so they're smaller. So now the other thing we did is we created we're gonna say git commit dash am, created game class, I'll capitalize game so it matches. Create a game class with block of cursor, HQ, and bases, and with functions to move cursor, main cycles through bases. Okay. So now, what should we do next? So we can now move around. One thing we could do is we could add we could add something to call the not make emulator active. We could call something to add add a method to basically move to HQ. That way we could call that. No, because see, we wouldn't know where the cursor is, right? If the cursor is in a random location, we wouldn't really if the cursor was here. What I'm thinking is, well, let's say the cursor's here, and we want to run with an arg with the arg parser. We want to say kind of move here. It's not a really great idea because it doesn't know where it is. So we would have to like count that out and calculate it, right? It's better to probably not worry about that sort of thing. So the next thing we'll want to be able to do is create units, right? So we can basically move around to the specific bases. We can move to the HQ. Now we kind of want to be able to kind of create units. So, from here we can move here, and then we want to build a unit, which is basically AA for infantry, and we have all these different units. So let's add some functionality for that, right? So that basically we'll come in here, and we can kind of move into this, open up, create a unit. We also want to be able to like end a turn, but let's not do that just yet. Okay, so come back here, and let's see. Okay, so we'll just start with infantry. So we'll say def create unit, and we'll say let's okay, so let's just do create unit. So do create unit itself. We'll say base location, tuple, and then unit. Yeah, we'll just say unit, and we'll just say like an int for now, right? Because so it's like a list of units. So what do we need to do if we want to do that? We need to self.move location self. And this is base loc, and then we need to press Z, and then we'll say for in range unit, press down, and then press Z. All right, and so that'll create a unit at a base location given the unit number. So what we'll do is we will say, I'm going to keep the move location at the end there. Because we're just running through it like one at a time, right? So we kind of have like an inherent like state, right? Like we know that there are no units, so we kind of already have that information like built in. So let's come here and we'll say self dot create unit, and we'll give it self.bases 0 and then 0, which is infantry. Is it infantry? Yeah, infantry. Okay. So we'll create an infantry unit on both bases, right? So now let's open this up, and we will run the prototype. So it moves there, creates an infantry, moves here, creates an infantry. Perfect. Moves back to the center. All right. I'm just going to commit. So what I'm going to do is I'm going to. So the other thing we need to do is we're going to need to kind of track where the units are. We're also going to need to be able to move the units around, right? I'm going to be doing a bunch of different stuff in main, right? So main is moving back to the center location, which is good because that's what we're like initializing it here. So next time we run it, So we'll need to save that information, but currently we're not. So I'm going to keep main like kind of flowing and updating with different things as we go, as opposed to until we like have that like knowledge representation built into this here. But I'm going to commit this create unit method and essentially kind of like I'm going to commit this, but I'm not going to. But the reason I'm committing is this new stuff we're added, right? So I'm going to say here. I'm going to say git commit am game wrote game create unit. All right. So now we know that we have these two infantry units. And so what I'm going to do is I'm going to end the turn. So that's another thing that we need to be able to do, right? So now we need to be able to move these infantry units. And then create more units. So the first thing I guess I'll do is I will move the unit. So we're going to need to have some representation of the infantry and where it can move, right? And so basically, I think here, if you look at it, an infantry can move 3 steps. And that's basically the main thing that we need to worry about here. It has other information about the infantry unit, but we basically can move 3 steps, and it's not impeded by any of these sorts of things. It was impeded by mountains, which, yeah. So when you look at like different locations, you can see that like for a unit to move through here on a road, it costs 1. On grass, it costs 1 for everything except tires. So if I have anything that has tires, like a Jeep, and it wants to move to this location here, it can move 1, 2. It'll cost it 2 to move there. If it wants to move here through the grass, it'll be 1, 2, and then 3. So it's faster to move that way. And then tires are slower, treads are slower, but units aren't affected by the forest. So basically, we need to be able to move these infantry units, and so we'll need some sort of like representation of a infantry unit. So let's just create another class. So we'll say create class infantry, and let's do we'll create a class variable movement. Yeah, let's just say movement. What does it call it in the game? In the game, it says. In the game, it is what is it? Move. Yeah. Actually, let's call it moves, I guess. So we'll say moves equals to 3. And then we'll have a def init self and location, and we'll say self dot loc equals loc. And if we want to do, we'll add a move. So we'll say move self dot. And so this is where like right now we're gonna basically need this kind of functionality again. So we should pull that out into kind of like another class. So we're gonna say to tuple. I'm gonna make this also tuple. So here we have move, and so here we're going to say if 2, 0 plus 2, 1 is 2, 1 is greater than 3, raise exception. Infantry can't. No. I'm going to say cannot move more than 3 spots. right? And then a lot of this actually is going to be able, like, we'll be able to actually create different. We'll be able to use like generalization. We'll be able to create like a hierarchy because all units are going to kind of move the same. It's just going to be information about like how far they can move and stuff, and like different things that are going to affect it. But for now, we'll just do this, and then we'll do the let's just copy this here because we're basically doing the same move code. So the first thing we're actually going to need to do is we're going to need to do press Z because we need to select the unit, and then we'll need to figure out where it's going to move to. So still self.loc to x count range. So this should all be normal, and then at the end we'll do press Z. Okay, so that should be everything for now for the infantry. So let's do this. Let's say let's update this, and we're going to say we have infantry, and the location is going to be the same as the base location right now. So we have an infantry at 331, and we have an infantry at 13. I don't know if I have to put that in a tuple or if that's going to accept it as a tuple, but I'm curious to find out. So we have an infantry at each of these locations. So we'll say I1, I2, and then we're going to say I1 dot move, and we're going to have it move. Now, I guess here's the thing. We could have it move relative. Because that's kind of like, it's interesting because the computer, which will have a visual representation of the map, will say, okay, I'm going to figure out where I want to move it to. Like, it can move to any of these spots, and I'm going to move it to that spot. Me, as a human, it's more interesting to think about it like, oh, I can move relative by like a certain amount. And so I'm going to add that function in as well. But I'm going to use the move function. So what I'm going to do is I'm going to say def move rel self xy, right? I'm going to add space there. And I'm going to add space there. Okay. So it's going to move relative xy, and basically, because I'm looking at the board and I'm saying, okay, it's at this location, I want to have it move over 2 and up 1, right? So this is really just for me, to make it easier for me to kind of like do stuff now. So the 2 location is going to be a tuple where it's going to be self.loc 0 plus x, comma self.loc 1 plus y, right? So if I want to move it like 1 by 2, it's going to take wherever it's currently at, it's going to add 1, and that's the new location I want it to move to, and then I can just call self.move with 2, right? And then everything else is handled. So this is just kind of like for human usage. Okay, so now what I'm going to do is I'm going to come in here and I'm going to say move rel instead, and I'm going to, so if we're looking at the board, right, I'm going to move this guy over to here, so I'm going to move him 3, 0, and this one, actually no, I'm going to move this one 3, 0, and I'm going to move this one 2, 1. So infantry 1, which is at 3, 1, I'm going to move it to 1. And infantry 2, I'm going to move rel 3, 0, right? And so if I said like 3, 1, that would raise an error because it would calculate that it wants to move to a specific position, and then when it goes to try to move there, it would then calculate this error here, which I'm going to leave in here as opposed to putting in here, even though it's simple to calculate x plus y. Because again, this is really the method that I'm going to keep around long term. Okay, so I'm saying I have an infantry unit in the one spot, I have an infantry unit in the other spot, and then move each one of them. And then let's create 2 more infantry. Let's just leave that there, and we'll create 2 more infantry units. So first thing I need to do is I need to move this back to the HQ, because that's where at the start of this it expects it to be. So let's run the prototype. And so it should move to the one unit, move to the other unit, move it, and then create 2 more units. So let's try it out. Oh, nope, got an error immediately. Type error, infantry unit takes... Okay, so yes, it can't do that. So it can... Well, okay, actually, I think it can. I think if I gave a star here, it'll unpack them. So I'm going to try that and see if it works. Nope. It still didn't like it. I know there's a way to do that, so I'm just going to look it up real quick. Tuple, we'll say Python, tuple, unpacking. And Geeks for Geeks. Let's see. I don't think this really has... No, see, it's the opposite, where... So let me say Python, pass 2 arguments to tuple method. Stack Overflow. Oh, did I put it on the wrong one? Yes, I did. I wanted to put it there. I think that was what I did wrong. All right, now let's try it. Infantry cannot move more than 3 spots. All right, so we got an error. Let's see. So we got this error, infantry. So we hit the infantry can't move more than 3 spots. It came from, so we had main 108. So move relative, which is clear, not more than 3 spots. And so that came into here and said, given this location. Oh, I see here. If this was relative, that was the problem, right? I was saying, oh, add these together. That is relative. I actually want, like this is within bounds. And so it's going to be like kind of similar method to this. But yeah, so I didn't do that right. So I want to say, what I actually want to say is if 2, 0, or here, actually, I'm just going to do it down here. So let me move these up here. So I'm going to calculate both of these first. And then I'm going to say if x count plus y count is greater than 3, then raise the error. And then, okay, that should all work. All right. So now let's try it again. So click in, and that just ended my turn. Just not what I wanted. And now it's still going. Okay, well, I don't know what just happened there. Oh, I wasn't on the unit. Right, so, and this is where I kind of need like, right, like move relative here. Okay, so I wasn't on the unit, which is why I went to that other menu screen. So here, what I really want to do is I want to say like, and I need the cursor to kind of be outside, because to be able to, so if I want to move this unit, what I actually need to do is I need to do self.move location. Okay. All right, so we're going to have to fix this in a second. So I'm going to do self.moveLoc, and I need to move it to i1.loc, right? And then I, at the end, need to say self.loc is equal to i1.loc, right? And then I need to do the same thing here. And so, yeah, there needs to be kind of like, I need to create like a separate class to represent the location of and this sort of kind of movement and stuff, which then I can basically pass in to here. It'll be able to this will be able to say, okay, well, move to my location, move me, and update kind of update yourself and do all that sort of stuff. But this should fix it for now. Okay, and so, all right, everything looks good. So yeah, it moves there, moves him to where we want him to, and then it does wrong stuff. Okay. Why? So it did the move relative. Oh. This should be I2, right? So it tried to move to I1 again. So I'm gonna comment this out for a second. Yeah, so I tried to move to I1, and I wanted to move to I2, move that unit, and then set the location to I2. And in this case, I'm going to move this back to here, because that's where we currently always kind of think. So I move this back here because that's where we always kind of think it is. So now move that, do that. Okay, got confused again. See, this is where I'm thinking, do I want to create a restart thing so I can kind of run through as I'm like doing this, because now all the units are getting kind of like confused about where they are. And we also don't have like a wait turn method yet. But what just happened there? So it moved it there. Oh, the reason is it was on this, and so when it hit A, it then got confused about where that was. Okay. Because it doesn't, I have to avoid these for now because it doesn't know the capture action, which is what it was getting confused by. So you know what I am going to do is I am going to restart the game manually. And I'm going to set those. Okay. So now we have a fresh game. So the first thing I want to do is get rid of all this stuff and just have it, we'll just run it one time to create units on the base. So that still works. Great. And then we move back to the HQ, which, yeah, okay. So now we'll start the next turn. And now we will add back in this code. So now we know we have the, so let's see if now this does it right. The other thing we're going to do is, so this one, I'm going to flip these. I'm going to have this unit move 3, 0, and I'm going to have this unit move 2, 1. So that way we avoid any like weird spots on the board to verify that it works. So now run it again. This one moves over here. Oh, okay. All right, so that was interesting. So the move action is actually different. So the move action, what we had was we had to click this, move here, click A, and then we have to click A again. Now I wonder if I can do that without waiting for it, or if I'll need to like speed it up to do it. So what we'll do is, so we need to actually have 2 of these. So I'm going to try this here. I'm going to get rid of the move for this one because we already moved him. And I'm going to come back in here. I'm going to move this to the HQ. So now we're just going to try to do it's going to move to this location, which is there. It's going to go to move it to here. And then it's going to set that location. And then it should create two new units. And we'll see if it can do that based off of, well, actually, I'm going to take out the create unit ones so it doesn't do anything else funky. Well, I'm going to see if it needs to pause or speed up for the movement of that to get it right. So let's try this out. So it should just move the unit and finish. Yeah, so that was good. And then move back to the HQ. Okay. So now I'm going to come in here. I'm going to get rid of this for a second. Add that back in. And run it again. And so now I'll just create 2 more units. And go there. And then we'll end this turn. Okay. So now we have all these different units. So we're going to come in here. So actually what we're going to do is we're going to add in this code. So we created an infantry. We're going to say git commit am created infantry class that can move itself. Okay. All right, so now we have that there. So now we have these different units here. And so what we're going to do is we're going to come in here. So now we have 4 units. We have 4 infantry. So this is 3, this is 4. We have the one on the base here. And then we have, we'll say these are the first 2 we created. So these are the 2 we just created, right? So these are the 2 that are on the bases. And we'll update these locations. So this one moved over by 3, so this is on 6-1. And this one moved over by 2, and then moved up 1. So this is not 4, right? So this corresponds, so we have I1, I2, I3, I4. And then basically this one here is I1, I2, I3, and I4, right? All right. So now we have these 4. So this is the sort of thing where when it's running, right? Right now we're running one at a time. It needs to, basically what it's going to need to do is it's going to need to save this, right? Save its state of where it knows the units are. It's going to need to have a map, right? So otherwise it's going to run off the map, or it's not going to know where buildings are to do specific actions such as capturing a building. So it's going to kind of need to know all of that, track all of its units. So that way when it becomes its turn again, it can kind of do something else that's kind of interesting, right? All right, so we have this here. So now what we're going to do is we can add these back in. And so I1 is the one that's kind of at the very bottom. So we're going to have it move up 1 and then over 2. So it's going to continue along the road. This one can move straight across now. And then we need to add in 2 more moves for 3 and 4. So we have 3. And we have unit 4. And what we're going to do is we're going to mirror these the moves that the other one did, right? So 3 can basically continue on the 3-0, right? That's what this first one did. So he's going to vacate, this infantry will vacate its spot, and this infantry will then replace it. And then same thing with this one. This is going to move over 2 up 1 so it doesn't land on the building again, right? So, okay, that's, moving things around. Now let's create more units, but let's create different units, right? So here we have create unit, and it takes a unit as like an integer. And why don't we do this? Why don't we add a string method and self, and this will return infantry. All right, so this here, what this is allowing us to do, well, I guess we could just use a type. We don't need to use it as a string. That's kind of bad programming. So we'll use it as the type. So here what we'll do is instead of passing in this, we will pass in a unit, which it doesn't know about. So we'll just say infantry for now, and we'll add a comment, infantry or other, right? And other type. And then so we're going to need a like a mapping, essentially. So we're going to need to say, we'll say units is equal to a dictionary, and infantry will be 0, and then we'll say mech is 1, and we'll comment that out for now because we don't have a mech unit yet, but that'll be the next unit that we'll create a class for, and then we'll abstract that out. So now what it's going to do is, instead of going this unit, we need to look it up. And so what we need to do is we need to say, we could say location, or we could say, unit location. So we'll say unit loc, or we could say like, right, because it's like where it is in like essentially like the list, right? Like it's like table entry in a sense. And so let's say, unit loc is fine. And so unit loc is equal to units dot get type unit, otherwise 0. So we'll add that in here, and then that should, so instead of in here, we should basically be passing in infantry, and so we need to pass it in as that. So okay, so basically what we're gonna, so this is because, right, so this is when it's gonna kind of know like, oh hey, this is a unit I need to track. How is this gonna end up turning out? So we'll say infantry here, and we will do the location that it's gonna be at, which is self.bases 0. This will be I5. And then we'll copy that and we'll do I6, make it 1. You can get rid of these comments. This will be I6, I5. And I'm going to move those around like that. All right, so then basically we're saying, okay, we're creating a unit, infantry 6 at the location of base 0, and then we're actually creating the unit. And we're passing the unit in here, which is really just to kind of figure out what type of unit we want to create. Create unit, this unit, right? We could actually say pass in just the unit and have it, create at that location, right? The base location is equal to the location we want to create the unit at, and then just check if that unit isn't there. But I'm going to do that next. I'll make that as like a. Wait, well, what did we do so far? Did we do anything else interesting? Not really. All right, yeah, let's do that. We're passing the unit instead. And so now we're going to get rid of base location. And we're going to say base loc is equal to unit loc. And then we basically want to check that if base loc not in self.bases raise an exception, you do not control a base there, right? So if you try to, so you have to, whatever location of the unit you want to create, it has to be in the location of a base that you're having, otherwise you can't do it, right? So we'll add in that there. And so we're creating this unit at this base location, and then instead we're just saying, hey, create that unit that we want, right? So that's a lot nicer. Okay. So now let's see. All the units are active. We have all the units, I think, correct in here. We're moving all of them, and then we're creating 2 more infantry units. So let's see. Let's open this up, and let's see if this works. Okay. Alright, so yeah, we're there, we're at the HQ, so let's run this prototype. So it moves over to this first unit, moves him up there, comes over, moves this guy, moves it there. Alright, so we got all those locations right, and it's able to move them all right. Now it should create. Okay, nope, we threw an exception. You do not have a base there. You do not control a base there. I wonder if that's because, I mean, it's a tuple, so it should work. Interesting. So let's check this out. So what are we doing here? So we have self.bases, so we'll copy this, bases. And then we're creating this infantry unit with the location of base 0, right? So we have bases 0, and that is added into the infantry as this tuple. I wonder if it's because of the star. That because we're passing in a tuple, it's having an issue with that. So actually, I'm not even going to do this. What I'm going to do is I'm going to say, actually I am going to do this. I'm going to come in here, Python, I'm going to say from prototype import infantry, lowercase p. All right, so I'm going to create an infantry 3-1. All right, so that has that, and then I'm going to say I equals that, and then I dot loc. Right, so I dot loc is 3-1. Now, what if I actually pass it in as a tuple, and then I do I dot loc? Yeah, okay, that's why. So it's getting the location wrong because here it's doing it as the tuple, and then up here when I'm doing it manually like this, I'm not doing it as a tuple. Honestly, it should be like a class in itself. But for now, what we're going to do is just unpack it. So this should be, if we do this, and then we do, I think, star here, and then we do I.loc. Yeah, that gets it right again. All right, so we're just going to come in here. Like, this is why this is not the best way to do it, but now that's all kind of correct. So we're going to exit out of here. I'm going to comment out all these moves because we already moved them. So I'm going to comment those out, and we're just going to create the infantry unit using this sort of methodology here. So I moved back to the location, and now let's run this. And now it has an issue. It threw another error, so let's come back out. Okay. Infantry object cannot be interpreted as integer. And this is here. And that's because I did not update this to unit location. And that's not right. That's right. All right. So now, try again. Perfect. And perfect. And we're back there. All right. Great. So what did we do? We basically updated create unit. So we'll say git commit am updated game create unit to use passed in unit class for which base and what unit type to create. Okay, so now let's add the mech unit next, because I think so. Okay, first we'll advance the game state to this one. We're gonna have to add in the locations of all these ones, but let's create a mech class, right? So like we have multiple branches now we can go down. We can create a mech class. We can start creating classes for like other units. We can fix this sort of like location thing that we're doing up in here. But for now it's kind of okay because we're still going to be creating these. So we'll have to have an internal kind of storage for what's going on. And we'll need like the map and stuff. So let's just create the mech unit next. So we'll come in here and we'll say class mech. Now the mech unit has we'll keep all this for now. We're going to abstract it out. And I know the mech has basically 2. And then this is going to be 2 here. In fact, what I'm going to do is I'm going to say this is moves. And I'm just going to say cannot move more than blank moves, more than blank spots. All this logic should be the same. So that should be good. We need to come in here. Add mech is the next unit on this list, so add in the mech. We'll need to abstract that out. Okay, so now we need to add these guys in. Right, so unit 1 moved. So now we need to basically, so this is the thing where what we're doing here, we're updating the locations as we go along. That's the kind of thing that we'll need to do programmatically. So for here, we'll update them. So this one went 2 by 1. So this is 8, 2. This will be 6, 4. This will be 6, 1. This will be 3, 4. And technically these are these base locations, but we'll add them in. And so I'm going to shorten that one because we're not using these anymore. And so this here is base 0 or 3, 1. And this is base 1, which is 1, 3. Okay. So now we have these moves. So that's another thing where we need to update the way that we kind of do the moves and like have the pointer. So I'm just going to make some notes in here real quick. So generalize units, generalize unit classes with unit superclass, create cursor class, for game to be passed to unit move methods, update automatically. What was the other thing we said? Fix unit init. Well, actually, let's say create point class to replace XY tuples. All right, so those are kind of three things that we need to kind of update, and then further, we need create board representation. For game, allow for multiple turns, and that okay. So those are basically kind of things that we can continue on doing. Okay, so we created the mech. Okay, we updated all these locations. Now we need to do all these moves. So we need to first of all add in a couple more moves here. For 5 and 6. This is getting long, so I feel like that's something. Oh no, I did the wrong one. This one. We can also just restart the game. Now that we kind of have like this stuff working right, we can kind of restart the game at any point and like kind of keep going things, right? Like I'm not gonna like obviously save this game to like reuse in future episodes. All right, so then this will be M1, M2. We have enough money to create 2 mechs, so we'll create a mech at each base location, and then M1, create M1, create M2. And how do we want to move them, right? So if I'm looking here, right, so this is unit, so they kind of like alternate. So this is 1, 2, 3, 4, 5, 6. So this guy, we're going to move, let's move him here. So that's 2 by 1, which is what we did last time. Actually, well, I guess we could do the same thing, right? So this was 2 by 1. This was 3 by 0, which would just put him straight over here, so that's fine. This one needs to go 2 by 1, and so these need to alternate. So this needs to be 2 by 1, and then 4 needs to be 3, 0, which is what. And then right now I have both of these as 2 by 1, which is fine. 2 by 1 and 2 by 1. So we'll just do that. Okay. So that's good. So this should before, what did we do? We just added the mech class. All right. So before, I need to move the cursor back to this location. Okay, and let's run this. And so it should move all the units and then create. So this is the sort of thing where, like, even if it has an internal representation, it currently does not know where the opposing units are. It also, like, even if it has, so that's the sort of thing where we could save the internal state each time, or we could calculate it every time. And that'll actually depend on how fast we can do that. But it looks like this is all working. Nice. Perfect. All right, so let's call, let's end this certain, right? So here, we are at the point where we could engage these units, but we don't know how to do that. And so we might have to quit. But first, let's switch back over. We'll go git commit am created mech class. Okay. So now we can generalize. So let's do these things, and let's start over with a new game before the game starts attacking us, and we have to, make even more kind of updates as we go, I guess. So we'll just start a fresh one. But let's first kind of code this unit class. So we'll say class unit here, and we'll go pass, and this one will be a unit. And this one will be a unit, right? So now, this method here, I'm going to take out, I'm going to move it up to here, get rid of this. And this actually needs to be self dot. And it needs to be an F string. Otherwise, it was going to just print that out literally, which we just didn't hit because we didn't have the exception. So now, if we look at this, these lines are the same. This line is different. This line should actually be self.moves, like that. So otherwise, this line is essentially the same. That's the same. These are all the same. That's the same. That's the same. That's the same. And that's the same. And then this is also the same, so we can move this up into here as well. And then now the only difference is this here, which the init is the same as well. So we can move that into here. And then we have this, and we can get rid of this here. And so at least for now, the only difference is the class variable here, which is just moves. So I'm going to move that. And right, so now we basically cut those classes down in half. We can then update this from infantry to unit and get rid of this comment. And then, yeah, the type of the unit should still be either infantry or mech. Okay, and yeah. All right, so now I don't want to update all these right now. So what I'm going to do, come back over here, and I'm going to quit the game. And start a new one. Okay, so now we have a fresh game. And we don't have any units. So we'll delete all these. I'm going to leave this in. Delete all these. And now we have 300 to start with, which is not enough to make a mech and another unit. So what I am going to do is I'm going to also leave that in. And basically what I'm going to do is come into here, and I'm going to say I1 equals infantry, and then this is going to be that star self dot bases 0, self dot create unit I1. And I'm just going to start with 1 unit. Right. So now we're at the start of the game, and so let's just create an infantry unit using the old method. Boom. Created the infantry unit, went there, and then we'll end the turn. Okay. So now we'll come back, and we're going to keep this I1 here. We're going to say I1 is equal to 3-1. Self.moveLoc, I1, move to I1's location, I1.moveRelative. We'll do, 2 by 1, and then self.loc equals I1.loc. Okay. So now we currently have 500. So let's create 2 more units. So we'll create an I2 on that base. And then let's also create a mech. So we'll say M1 equals mech. We'll create on the other base. And we'll do self.create unit M1. Right, so now we should move the unit we just created and then create an infantry unit and a mech unit. So we'll come here, let's run this, move this guy, infantry, mech, and we stop. All right, so let's end this turn, and we'll just make sure the mech and the infantry all move right. We'll do one more pass, and so we'll create a copy of this one here and here. This will be I2, 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 and I2, and then this will be M1 for all of these. This will be mech. So this one has already moved relatives. So this one's at 5-2, and we'll have it do a 2-1 again. This one this one's at 3-1, so we'll have it do the 2 by 1, and this one is at 1-3, and it can only move 2, so we'll go 2-0, and then let's just flip them. Let's do this one at base 1, this one at base 2, because we have 400, so we can create both. All right, so now if this one works, we'll have successfully created and moved all the mechs and stuff too. So move that one. Move the mech. List. Oh. This was supposed to be 0. I'm just going to comment out all this stuff and then run it so it does the last thing, which is, we also need to, it threw an error, so it's not in the right spot. So move back to the right spot, and now it'll create the mech. All right, yeah, so that was just my mistake in the indexing there, but everything else works perfectly. So we'll uncomment that. And yeah, so basically what we did was we created this, or you just moved those functions in there. And so we'll say done, git commit, and created unit superclass. Okay. Let's see. So now, yeah, the board representation for the game would kind of help move stuff around, but that's fine. Create cursor class for game to be passed to unit move method, right? So that's basically with this stuff here. So let's say class cursor. This will be def init self. And so we're going to start at the HQ location. So self.loc equals 22. Basically this XY. All right, so we have that location. And basically we're going to need to update this stuff. Now, unlike the HQ, so let's move, we can move these methods into here, right? So this within bounds takes a point, which is a tuple. It knows the map, the cursor knows the map size, right? That makes sense as opposed to the game knowing the map size. I mean, like, I guess both of them in theory need to know the map size, but it's really the cursor that's moving around that needs to know the bounds of the map, while like the location of things on the map make more sense for the game. So this kind of all still is good. This within bounds now doesn't exist, but that's fine because we need to move this up into here anyway. Right, so if you take a 2 for a tuple and it's within bounds, then do the same sort of mathematics to move stuff around. And those shouldn't reference HQ or bases, so these should be good. So now, is within bounds is only used in move loc, and move loc is used for create unit. And it's also used in this method here. So what we're going to need to do is we're going to need to replace location. Is location moved anywhere else down here? I guess self.location. Yeah, so that's moved in these locations too. So that's where it's kind of updated and stuff. But that's fine because this updates, when it moves, it updates itself. So as long as it's being done through this class, that should work fine. So we're going to do self.cursor is equal to cursor. And in fact, what I'm going to do is I'm going to here take a point tuple and make this point. And now what I'm actually going to do is say, okay, so you have that information, and then you're creating a cursor to use, and this is going to take self.hq. All right. So now we have this cursor. Now we need the move loc doesn't exist, right? So move loc is now not self.moveloc, it's self.cursor. Cursor.moveloc. So that's going to move loc, move to the base location, create the unit, right? And this in here will update, right? So when we say move to that location, it'll update the cursor. So instead of updating, like in move loc, it updates it anyway, and that updates this here. So it's still like, we basically just abstracted that out. But what does that now get us? Now it gets us into here, where this move loc is again going to be this dot cursor. Right? And now I2 or self.loc doesn't exist, right? So this is actually going to be cursor loc. And this is a move loc as well to HQ. think I got all the spots. So I'm going to test this out first, and then what we'll do, so we'll do this in 2 commits. So we'll test this out, make sure this works, and then we'll do the second thing, which is to, instead of moving to the location here and then moving this, we'll say move relative, we'll pass it a cursor and where you want it to move to, and then it'll do everything to kind of, the cursor should like update and stuff, right? So this all should work. So let's update based off of where we have the units, right? So we currently now have, I wonder if I should start over again. No, this is fine. All right. So currently we moved this one to 7.3 now, and 2x1 still works for that. This other infantry is now at 5.1, and 2x1 works for that one as well. And the mech is now at 3.3, and we'll move it up 1.1. And so now we'll take this one. Also, here we'll add in these 2. This will actually be I3. And this will be M2. And this is an infantry. All right, and so this one is at 1.3. And we'll move it to 1. And this one is at 3.1. And we'll move it to 0. And then I will create one more unit. And we'll create a mech on base 0. Okay. So now let's see if we got this cursor code correct. All right. So we're in the right location. Let's run it. All right, so far everything looks like it's tracking right. Oh, got the wrong spot. All right, now it's just out of whack. It's confused. Okay. I don't know why I got the wrong spot, and I'm gonna just start it over because so we'll say new. Okay. So we're going to start new here. We're going to remove all this stuff. And we'll just start with 1 unit. So we'll say I equals infantry star self.bases 0 self.create unit I. Okay, so we'll start with that. Let's see what happens. All right, so it gets that right and it moves back to the location. So we're good there. Because I don't know if it was because we need to end the turn. I don't know if it was because the issue was because I just wrote the spots wrong or not. Okay, so now we have this one. So we're going to say I1 is at 3.1. We'll do I1.move rel 2x1 self.cursor.loc equals I1.loc. And then we'll create a mech this time. we'll go to the other base, create M. All right. Let's see. Nope. Just got it wrong. Just got it completely wrong. I think. So the first thing it should have done was create the infantry unit at 3-1. Or it should have moved relative. Oh, I missed this line. I need self dot cursor dot move loc. That was why I didn't move to the location of I1.loc. Okay, that was my mistake. All right, I was missing this line. Oops, I was missing this line in here, and moved to it. So it didn't move to it. So then it just tried to do a bunch of wacky stuff, I guess. All right, so let's try move there, move relative, create the mech, and the turn. All right, so it looks like it's working, right? So now I'm going to commit this. I'm going to say git commit am created cursor class for game to move with, or to track, for game to track cursor loc. Okay. So now I want to pass that in, right? So basically, instead of doing these calls here, I want the infantry to take a cursor, right? So instead of updating the cursor here and here, I want this guy to update the cursor. So I'm going to come into move relative. I'm going to say move relative cursor. And I need to move it above okay. I need to take this and move it above the unit. The unit class there. All right. Cursor, and then XY. And then this will move cursor to there. And then in here, we'll say cursor, and we'll basically want to update the cursor. So we're pressing A at the location that we're at. And then we're moving X count, Y count, and then we're setting loc here. We'll also need to set cursor, or well, actually, I guess, no, we want to use this move function here, right? Yeah. So instead of this here, right, which is doing, so these are doing the same thing, right? Instead, we want to do this here. So here we want to say cursor dot move location or 2. I was looking at the wrong thing. And then we don't need any of this. So you want to press C, move, press C, and then press C again. And then the location of the unit is still equal to 2. Yeah, and then so I mean, like this here, right? We like this is kind of analogous to this is within bounds. And so we could abstract that out as well, but in fact, I'll do that in like the next thing. Okay, so we have all this, we have that. Now we don't need to update the location. Okay, so actually we need to, okay, so we have this move, so that's taking care of this because we're handling that. And so we're saying move relative 2 by 1. So we need to first move the cursor. So first, actually, we need to move the cursor dot move location to self-loc, right? And that's basically what we're doing here. Move the cursor to that location, right? So now we don't need to do that anymore. We can just call move relative. It'll then call that to move to location, press that, and then move to the location we want to move it to. Okay, that should work. Hopefully I didn't introduce too many bugs. All right, so we currently have 2 units. We have an infantry, which is now at 5-2, and we'll have it move another 2-1. And then we have the mech unit. Mech unit is at 1-3, and we'll have the mech unit move relative 2 by 2 or 1 by 1, and then we'll create another mech unit at the other base. Okay. And I was blocking that entire thing that I was doing while I was coding. Chat, you're supposed to keep me updated on this. Yeah, so okay, so what did I just do? So I moved the cursor above so I could update this here. I'm passing the cursor into the move function, the move relative. So actually I need to do that here. I need to do self.cursor. Self.cursor. All right, so I'm saying move relative with the cursor 2 by 1. So that comes in here. It still pre-calculates if that move is okay, like if the move for the unit is okay. That then calls into move location. This makes sure that it's moved. It gets moved within. It's still moved within bounds, but it moves to the location of the unit. Presses the button and like clicks the unit, moves to the location we want to move to, presses, and then has it there, and then it says that okay, well the location that we're at is now the 2 location, right? So that's all I was doing. All right, so now let's try this out. So it should move over to there, move 2 by 1, move over to the mech, move relative there, and then come back down. All right, perfect. All right, so that all worked nicely, and basically, if we look at the diff here, right? So I mean, this is an awkward diff because we moved it. So we moved the unit below cursor, which isn't really interesting, and we essentially update, and we also changed it, which was part of it. So we updated unit to use cursor. Is basically what we did. Git commit am. Updated unit to use cursor for movement, right? Because now we're not calling any of the like previously in here we were actually moving the cursor using the press buttons. Now we rely on the cursor to actually use the press buttons here, and then update itself, so we don't have to update it. We don't have to come in here and say move to the location of the unit, right? Because the cursor knows where it is. So we move that into, we move that what we were doing into here, right? Because the cursor is now in here, so we can just move to the location there. And then we don't have to update it here because it updates itself as it does this move call. So the other thing I'm going to do is I'm just going to quickly pull out this here into a method for unit to say def, similar to this is within bounds, is movement allowed, and it's going to be self, it's going to be 2, it's going to take a tuple, and x count is equal, so basically this, right? We're going to say x count is that, y count is that, and then if that's greater than your moves, you can't do that, right? And then so throw an exception. So here we're just going to say self dot. Did I return? Oh, I guess actually what I did was I said, so here, in this one what I did was I said, I threw the exception outside, so I'm going to do that same thing. I'm going to mimic what I did with that one in this one. So I'm actually going to keep this outside. And I'm going to say if not self dot is movement allowed to, then raise an exception. And then in here, this is going to return a bool. This also is going to return a bool. And so this is going to say that, do that and then return x count plus y count is less than or equal to self.moves. Okay. And I guess let's just test that as well. So now in here we have the I need to end this turn anyway. So now we have infantry 1 is at 7-3 and can still move 2 to 1. The mech is now at 2-4 and can't move up anymore, so it's going to move across. And then we have another mech that's at 3-1 and it's just also going to move across. And then we'll create an infantry at base 0 as well. Actually, let's create at base 1. And then this is going to be I. Okay. So now let's try this. Right. All we did was we updated the bounds, so it honestly shouldn't be an issue. It shouldn't even really hit most of it, but. Cool. Okay. So now we'll come in here and we'll say git commit am refactored out unit is movement allowed. All right. So this is actually now done. What time are we at? All right. I think I might just do this last one, and then we'll create so we have most of the interactions kind of down and coded decently. And so I'm not going to create the board, the internal representation of the board and stuff yet. What I will do is I'm going to add this pointer class. And that's going to have to be above cursor because that uses it. So we're going to click class point def init xy self.x. Well, I guess I could just, I can create a couple. Self. No, I'll do self.x self.y equals xy. Now, how do I normally create them? Am I creating them? I am creating them with tuples here, but that'll be point. All right, so this should be okay. So we have point here. So we'll call this loc. So now location is not a tuple. This here will be a point as well. And this here, and we'll call this. So, okay, cursor, give it a location, which is a point, and that is this point within bounds. So the map size is this point. And I could abstract out this as well if I wanted. I could say def is within bounds. Lower point why is it, why can't it upper point, why is that not getting that right? Wait, how can the type helps not use itself as a type? That makes no sense. Python type help. It's not possible to use self to type hint the current class, for example. Okay, so this should be self. Let's see. What does this say? Type hint, same class. All right, so it looks like the suggestion. So I can actually I can do this if I do from future annotations. It looks like then I can say point. And that's not double underscore. Up and blocking it again. So from future import annotations, and that allows me to have point in here. All right, cool. Okay. So now I can do this within bounds here. I can say if self.x is less than lower.x, or self.x is greater than upper.x, return false. If self.x is less, or self.y is less than lower.y, or self.y is greater than upper.y, return false, return true. So now in here I can just say, is it within bounds? Well, that's the map size. And so return point dot is within bounds 0.00 and map size. Okay, so now this 2 is also going to be a point. So then in here we have the x count. So we could say, so we could also check this out. We could say difference or distance, a distance of self to a point, return a point. This should return a bool. And then here we're just going to do x is equal to self.x minus, or no, 2.x minus self.x. Y is equal to 2.y minus self.y. And then return a point x.y. And then, so now in here, we can just say d equals, or we'll say dist equals self.loc, which is a point, dot distance 2. Now we don't have x count anymore. Instead, we have distance.x. Update those. We don't have y count anymore. We have dist.y. Update these. And now the point location is going to be equal to what the 2 location was. So that can stay the same. So that is all, that all looks good. Close that. So this location is now going to also be a point here. And this will be a point. Is movement allowed? Now I could, if I wanted to use the point thing here, right? So there's 2 things I could do here. If I wanted to use the distance method to a point, right, here, I would have to say, well, I'd have to figure out what the bounds are, and it's not like a square, right? It's like it's like a star essentially, right? Because a 1 by 1 would be like a 1 by 1, like if it's well, is it, wait. Yeah, because if it can move 2, it can move 2 up, it can move 2 over, but it can't move 2 diagonally, right? So it can only move 2, it can move to like that spot, which is what kind of creates that star pattern. So that I couldn't really use, but I could say like, oh, well, you know, what is if I have this 2, what I could say is, well, what is like the magnitude, right, of this? So I could say def, is it magnitude? No, I think it's an I. Magnitude of this, and have it return an int. And essentially, the magnitude is just return self.x plus self.y, right? So if I want to move, well, okay, so I guess does that... So that's actually interesting now that I'm thinking about it. Is this movement allowed, right? If I'm moving somewhere, so if I'm at a point and I want to move one direction, right? So I was always moving to like the upper right, right? So for example, if I'm in this location, I want to move a 1 by 1, then I want to move x by 1 and y by 1, right? And so that's 2, which is fine. Now, if I want to move down here, though, I want to move x by 1 and y by negative 1. Well, that's actually not 0, right? I can't, it's not 1 plus negative 1. Well, that's 0, and that would say, oh, well, that movement is allowed in the current logic of how I'm doing it, right? I actually need the absolute value of these, where how much am I moving in x, absolute value, how much I'm moving in y, absolute value, right? And so if I'm in here, and I want to say, well, what is the, right? So it's kind of what I'm doing, like in here. This should be the absolute value of this one and the absolute value of this one. Now, I could use the distance, right? Is this movement allowed? I want to move to that point. So then I want to move a distance of, you know, self.loc.distance 2, right? So that is the distance that I need to move, and so then the magnitude of that distance is, so that's doing this calculation here, right? It's doing this calculation, and now the magnitude is actually of this, right? So what I actually want to do is say apps x plus apps y and return that. And then, so then here I can return the distance.magnitude is less than or equal to self.moves. So that actually fixes that bug that I hadn't noticed, because on this map I'm always moving to the upper right. So that fixes that there. Cursor, this is also going to be a point here. Is movement allowed? That's fine. Move location for cursor now takes a point. Self.loc is a point. 2 is a point. So those should all just be fine. That resets it. Move relative xy. So this should be 2, should be now a point. Which should be the location.x and location.y, add in the move relatives that I want to do, turn into a point, pass the point in there. So that should all be good too. Those are fine. We'll make this a point. We'll make this a point. And we'll make this a point. That unit, that's fine. Base location, unit.loc, which is the point. So the base location is a point. If this is not, this might not work. I might need to create an equals method for that. So we'll test that out in a second. But otherwise, unit location, unit location is a point, so this is a point. Passing a point to the cursor is fine. Type of the unit. In here, I'm going to actually just turn this into that, because for now I wanted to throw an error if I try to use a unit that doesn't exist in there. But otherwise, unit location is fine there. So now infantry, right? So these unit classes now take a point as the location. So these need to be points. And self.hq is a point, so that's fine. All right, so now basically we need to kind of update these here to match what we have. So and the other thing, yeah, so that'll be a point. So okay, this is now point and this is 9, 4. Move relative is still that. This is going to be 0.44. And this other mech, this is supposed to be mech 2, is going to be at a 0.51. And then we have another infantry I2 is equal to infantry. And this is going to be at a point at 1.3. And then we need to move relative for this one. And this now takes a point, so this can just take it as that. And create another infantry, and we'll create a base 0. All right, so now we need to, I'm going to retreat this one. So this is going to be -2, -1. I'm then going to take this mech, and move it 2 over again. I'm going to take this mech and move it 1 by 1. I'm going to take this infantry and move it over 2, down 1. And then I'm going to create another infantry. Okay, so that should work. And let's see if we throw an error or anything. So let's run this. So it's going to retreat him. Advance those. That. Okay, so we got an error now on this last part here. So all the movements were fine. So that's good. Built-in function math object is not subscribable. Units.get. Well, units. That's interesting. So, well, for one, it looks like, or no. Well, when do we do this? Is the one that we did, right? And so we didn't hit that error. So it was able to say that this was. It was able to say that was a base. So that works. So we don't need to, right? It was able to tell that those are the same point. But I'm also passing it this. I should try passing the other thing. Okay, so we hit this, and then we tried to get units here, .get, and I didn't want .get. That was why I wanted that there. Okay. So now I'm going to comment out these for now. And I'm going to do that, and I'm also going to do a mech. Let me see how much. All right, so we got 1,000, so I can create a mech. So I'll create a mech, and I will do that at a different point, right? So it's not going to be the same exact point. It's going to do, now, like this would be okay, right? Like if I always said, oh, hey, do it on this base or do it on this base, that would be fine. But I'm going to do it like this instead. So the other one is going to be 1-3. And then I'm going to do self.create unit mech. And so I think this one's going to throw an error, and I'm going to have to create an equals operator. So let's run this. We're at the right spot there. So we'll run the prototype. That worked. And then, yeah, so it said you don't control the base, right? So now I'm going to comment this out for a second. And we're going to create an equals method for point. So we're going to say def equal other point returns a bool, and here we'll say return self.x equals other.x and self.y equals other.y. Right, so that means 2 points are equal if their x's and their y's are equal. So with that update, now we're just creating this here. So we'll come over here, we'll move the cursor back there, and we're in the prototype, and that works. All right, so now we'll create a point class. So we created a point class with within bounds, the distance, and the magnitude. So we'll say git commit am created point class. Okay, cool. So now all right, so I want to add that into that same thing. So I'm gonna reset that. I'm gonna go reset head of the chain back 1, so that's back, and then we'll commit that as is. Okay. So now the next things we can do is allow multiple turns, allow it to understand what the board is, right? So instead of going and having to end the turn and restart it again, we want it to end the turn, and then we want it to basically keep track of where all these units are, where they're allowed to move on the board, what actions they can move on the board. We can always input. We'll probably start with inputting the unit, like the opposing units locations, and then we'll upgrade it so that it can kind of read where these opposing units and stuff are. But yeah, so for now, let's just kind of recap quickly what we've done. So the only thing we're using here is pi direct input for mouse clicks, and the move to, which are both the mouse functions we use to basically move over to where the emulator is and click it. And then we have the key down, key up, and the press. The key down, key up we're using for the space bar, and the press is what we're typically using to interact. We created this method so when we're at the start screen, we can basically get to an empty board, which we can do just by passing -s, right, or --start. So it'll then make it active. And then if we want to start, we'll create the board game, and then we can do whatever we want with the game by running main. Otherwise, we can just skip that part, which is what we've been doing. So now we have a point class, right, which is basically just a wrapper around what we were using a tuple for with x and y. But that allows us to have this logic here where if you're given 2 points, kind of a rectangle like the map, and you can say, well, is this within bounds of that rectangle? Is this point within bounds of that rectangle, right? You can also do a distance to another point, right? So, which we're returning as a point. And that might seem a little weird, but if you're used to kind of vector math, if you've done a bunch of physics and stuff, that's typically how things are represented. Where you have a point, right? A vector is basically the distance is, it's not like an actual distance, it's really a vector distance, right? So it's really, you could say, oh, we have a vector. But a vector is basically, so from this point to this point, right, we have this distance xy, and we're saving that in a point as well. Magnitude is basically, so if we have, this, right, and it's 3 and x and -2, right? Again, it's kind of vector math, and so that's going to be 5 movements, right? So it's 3 plus 2 is 5, and then 2 points are equal if their x's and y's are equal. We created a cursor which tracks the main interaction point that we have, and does all the left to right movements. So then all we have to do is basically click Z, which is the input button. So a cursor, right, has its location, right, which we can set when we start out. Within bounds, basically we can say that we can basically check given the map size. So the cursor knows the map that it's on. And so basically it can check whether a given point is within bounds on its map, right? Now, I guess in theory, this could be done before you move location, right? But because the cursor is going to move to a location, it wants to say, is the point that I'm given within bounds? And so the cursor is aware of the map size, and can know like where it's allowed, where it can kind of move to and stuff. That might, logic might move around. But yeah, so if you want to move the location of the cursor, you give it a point that you want to move to. It checks with it's within the map. It then basically calculates the distance from its current location to that point. And then it uses the X and the Y of the distance to move either right, left, and up, down. And then it sets its location to the point that it just moved to, right? So that's fairly straightforward. We then have the units. So a unit basically has a location. Its movement is defined in its subclass. So it has a certain number of moves that it can make. It gets more complicated when you take into account the environment and other types that aren't infantry and mechs, as well as weather. But for now, it can basically say that, is its movement, the moves that it's allowed to make, is that magnitude of the distance that it is allowed to move appropriate, right? So it basically says, okay, what is the distance I'm trying to move based off of my current location to where I'm moving? Is the magnitude of that distance less than the amount of moves I want to make? If so, the movement's allowed. So if I want to move it, I give it a cursor so that it can move, right? I give it the cursor that tracks everything. I give it a point that it wants to move to. I make sure it can move there. And if it can, the cursor moves to the location of my unit, clicks the unit, moves the cursor to the location I want to move to, clicks that location, and then finalizes the movement, right? When we add in, for example, the buildings and stuff, it'll be able to do other stuff. It'll be able to attack other units. That'll be part of kind of a move there. And then it updates the location of the unit to where it just moved it to. Move relative is for us to kind of use to make it easy, so I don't have to sit there and say, right, because I don't have a grid on the map. So it's just like, oh, okay, move this one 2x1, 3x1. So it just says, okay, what is the current location of the unit? And then move it that relative distance, and then use the move function to actually move it. I then have the infantry and the mech. And then I have the game. The game knows where the HQ is. It knows the bases that I start with. And it knows that the cursor starts at the basis point. It can then create a unit. The game can create a unit. It's really like a player, essentially. A player can create a unit by, so it has this unit map. These are like the index in the base. So it says, okay, create a unit. Well, I want to create a unit at this location. Right, so it takes the unit's location, says that's the base location. If I don't have a base there, then it throws an error. Otherwise, it moves to the base location. It clicks the base, it figures out what type of unit I want, moves down so I get to that point in the map, and then builds the unit. And then the main function itself, right, has been just kind of alternating of using the different movements of the units and the building of units. Right, and then I have the arg parser to allow me to do that. So super, fairly simple so far, but we've got a lot done. We're able to kind of engage with the game. Once we kind of have the representation, we can add in actions for things. We'll kind of be able to do even more. So let's check out the log real quick. So if we look at the log, we had a bunch of commits, right? Setting up the project, installing PyDirect input, kind of writing out some basic code. We added the arg parsing, right? And then we started kind of writing all those different classes, refactoring some stuff. So got a lot done. I'm going to tag this as episode 1. So now if you're looking, you see the tag here for episode 1. And yeah, so next time we will continue with more interactions, as well as kind of inputting the knowledge, right? So that the computer is aware of the game, and once it has that knowledge representation internally, and it has these abilities to kind of act within the game, we can start then having it try to figure out what it should do, and that's where the artificial intelligence comes in. So until next time, see you.